Hello and welcome. In the previous tutorial, we looked at transferring data from a business service to an action class and then from there to a JSP. And I promised you I'll take you behind the scenes and we'll try to understand how the data flow happens between the action class and the JSP. So if this is a high-level picture of our application the way it is right now, this is the transfer that we are interested in. So we have a business service result going to an action class, and then that is displayed in the JSP, of course, by using the struts2 tags. So actually it's the arrow should be over here, but I think you know what I mean. So we are trying to understand this data transfer, how it happens, why it happens, and all that stuff. So before we start here, if you're familiar with servlets or even with struts1, you would be a bit surprised at what I did in the previous tutorial, which was taking this data and keeping it as a member variable of the action class. If you remember, we called the business service and then we took the output of that business service and saved it as a member variable of this action class. And the reason why you would be surprised if you were familiar with servlets or struts1 is that the way the servlet or the struts1 action works is very different in this scenario. So let's take the example of servlets. Say you have a servlet object that's the servlet is deployed in a Tomcat container. You have an object here and you have a JSP that's deployed, and the servlet redirects to the JSP. Kind of the same setup, but not using struts2 that we're using. It's servlets and JSPs. So let's say you have two different clients making a request, and that request is served by the servlet. So what does Tomcat do over here? Tomcat does not create two different instances of the servlet. It creates two different threads. So each thread over here is gonna address the request that has come separately. So both these threads are of the same servlet. Thread 1 addresses request 1 and thread 2 addresses request 2. So this is how servlets work. They are threads, and then each thread addresses a particular request that comes in. So the thing with the thread-based execution is that there's one thing that you have to focus on now when you're creating servlets. You have to make sure that your servlets are thread safe. Now, what does thread safe mean? Thread safe means that if you have any data or any states inside this object that could cause problems when there are multiple threads trying to access the same object, you should make sure that that does not happen. Like, for example, let's say you have a member variable over here and you're saving something to the member variable. This is obviously a problem when you have different threads, because both these threads are going to access the same member variable. It's one single object. Remember, there are different threads, but the same object. So this is a problem. You cannot have data as member variables because it's going to lead to problems. Say thread 1 calls the business service, saves some data over here, and then by the time it's trying to render the JSP, there is another thread, thread 2, that saves something else to the member variables. So that's a problem. It is not thread safe. You want servlets to be thread safe. So what this means is that your servlet methods will obviously have all the data inside it. You would not have member variables as such, and that's how you make the data isolated to the threads. So having said this, now how does actually data get transmitted to the JSP? So in this scenario, I have thread 1 calling a business service, thread 2 calling a business service. It might be two different outputs. Now how do I transfer the right data to the JSP if I cannot save this as member variables? The way the servlet API works around this is by having a separate storage space for your data. So you would not have member variables. Let's take that away. So what the servlet API does is it creates separate storage spaces. So we have request objects, and we also have session objects, which I'll come to in a minute. But what these request objects do is whenever there is a request, there is a new request object that gets created, and you can use these request objects to store your data. So when thread 1 calls the business service, It says request.setAttribute, thread 2 calls request.setAttribute. Since there are two different request objects for the two different requests, you don't really have this kind of a race condition between threads. One thread cannot override another thread because there are two different request objects. And then the request object is accessible in the JSP as well, and then you can get that data using some smart tags or expression language, and then you get the data and you can render it. So this is pretty much how you would manage this data transfer if you're working on servlets and JSPs. So you would typically have two different objects which you would use to transfer the data. One is the request and one is the session. And what you store where depends on the nature of the data. See, you have some data that you want to just pass on to the JSP just for that particular request, and then when it's done, you're done with it. You don't need the data anymore. In such scenarios, you would use the request object. And then there are some data that you would need to save for the length of the user session, like the user's logged in information. So such things you wouldn't want to keep it in the request because this gets created for every new request. So you would save such data in a user session. So these are the two objects that you would use when you are transferring data from servlets to JSP. So you put this in one and then you retrieve it in the other. So we are given the objects to use, but we need to do this push and pull of data ourselves. This is not automatic. We need to give names for these attributes. We need to save it in the servlet and then access it in the JSP. And this has to be done for every servlet to JSP communication that needs data transfer. Okay, so now that we know this, now how is struts2 actions different? So what we've done in our action is we have saved the data of the business service in a member variable, which is something that we learned we should not do in the case of servlets. And the way this works is because struts2 actions do not have this threaded model. So in the case of struts2 actions, we have new action objects that are created for each and every request. So this is how it's different from servlet. Servlet objects are not created for each and every request, but in the case of struts2 actions, you get a new action object that gets created whenever there is a new request. So let's say you have 4 different requests. You won't really have 4 threads of the same object. You have 4 different instances of your action class. So whatever action class we've written, we have written the tutorial action, right? So whenever there is a request, there is a new instance of that action that's created. So what are the implications of this? This, of course, changes the way we work with action. And one implication that's very straightforward is we can have data as member variables. You don't need separate request objects because there is already a unique object that gets created for each request, which happens to be the action object itself. So you don't need a separate request object. You can actually have member variables that contain the data that we get from the business service and that needs to be transmitted to the JSP. So here the action class kind of doubles up as a model object. You don't really need a separate model object. Of course, you can choose to use one, and in many cases we do, but we don't really need a separate DTO or a separate model object. You can actually have an action class that contains all the data and that behaves as a model object. Okay, so now we know how this works. We know how we can save data as member variables and then carry that over to the JSP. Now, the last piece of the puzzle is to identify how this data is actually accessed in the JSP. Because again, the question remains, in order to get the data which is stored in a member variable, you need to have an instance of that object naturally. So since we do not have that instance, how does the JSP, or in this case the struts2 tag, get a hold of this data? In the case of struts2, it happens by using what's called as a value stack. So what is a value stack? Value stack is actually one of the really important objects in struts2. It's kind of used in a lot of different areas in the framework. A lot of things access the value stack to get the work done. So we're not going to cover all the details with the value stack, but we'll have a look at a quick introduction and see how it affects what we're discussing here. So a value stack is not really a stack in a traditional sense that we use for data structures. So you have a stack data structure where you push objects and pop objects. So even though it kind of behaves like that, it's not really a stack in a traditional sense. And this value stack is used by the struts2 framework to save a lot of important objects. And as I said, different components of the framework use this value stack to get those objects and also to save objects. And one of the things that the struts2 framework does is, since we have now an action object which also behaves as a model object that we've seen, the struts2 framework actually saves this action object onto the value stack. So we have a new action object gets created for each and every request, and that new action object is actually saved inside the value stack. And then in our JSP, we're using a struts2 tag. Now this tag accesses this value stack and gets this data. So this is actually how these member variables information is going to the JSP. So the action object with all the data as member variables is getting saved in what is called as a value stack, and then the JSP tags accesses this value stack. Okay, so there are a few tricks that value stack performs. It kind of helps ease the way we code, but then it's important that we understand it so that we know what's happening. So one of the things that the value stack does is it behaves as a virtual object. Now, what do I mean by a virtual object? Well, here, let's say you have 3 different objects inside the value stack. We're not worried about what these objects are. We know that an action object saves itself in the value stack, but we don't still understand what the other objects are. But just go with me here. Say you have 3 different objects, and each of those objects have a few member variables. Now, what the value stack does is it kind of eases the way in which we access these objects. Let's take the example of our action object, which has some data in the member variables. It's very unlikely that we would be interested in the action object in order to execute code. We are actually interested in it because of the data it contains. The code execution, which is the execute method of the action object, is already taken care of. It's the controller which executes it. When a request comes, we have seen all that stuff. Now, we are worried about the data. Now, the execute is executed. We have data as member variables of the action. From now on, we would very likely be interested only in this data. We are not really interested in the execute method. So the member variable is all we are interested in. Now, in order to access the member variables, we need to get the object and then get the member variables. But since this is a common thing that we would do, so what the value stack does is it kind of isolates out all these member variables and it behaves like a virtual object which has these member variables. So imagine these member variables are all taken out and then they become part of this value stack object itself. So they are not member variables of the objects that are in the value stack. They act as if they are member variables of the value stack itself. Now let's say this object had a member variable called best tutorial website as a string. So we would need to have some way of traversing this object graph in order to get that string. So we would have to have a value stack dot get this object dot get best tutorial website string, right? So that's the way you would reach the string data. But instead, what the value stack does is it isolates out these and acts as if these member variables are part of the value stack object itself. So that way it's very easy to access this data. You don't have to worry about doing a get tutorial action object dot get best tutorial website string. You can actually say get tutorial website string of the value stack, and then it gets this data directly. You don't have to worry about traversing the stuff. So the advantage is obvious. You get access to the data very easily, and since the data is all we are worried about in the value stack, it's a very handy thing to do. So so again, to summarize, it's not really a stack in the traditional sense. It does stack up objects one below the other, and then it behaves as a virtual object that contains all the member variables of the object that it has stacked. So you don't have to go to the object and then to the member variable. You can directly say value stack dot member variable, and you get those member variables. So it makes it very easy to access those member variables. Well, there is actually one catch here. How about if you have two objects in the value stack that contain the same member variable name? How does the value stack handle that? Because that's a problem, right? We have different objects which can have member variables, and then the value stack kind of assimilates all those member variables. Now, what if both of them have a common name? How does the value stack handle conflicts? Well, conflicts are handled this way. It's a stack, actually, even though it's not a traditional stack. It has objects stacked up one below the other. So what the value stack does is it kind of looks from the top down, and whatever is the first member variable that matches the request, it just hands it over. It's as simple as that. So what I mean by that is, let's take this example. So I have an object that has an int count and a string file name. I have one more object below it in the value stack which has an int count, and I have another object below it which has a string file name and an int list size. So again, let's say I want to access the count of this object. So what I do is, instead of doing a value stack dot first object dot count, I just do a value stack dot count. So what this does is it just goes from the top down, takes this object, sees if it has a count. Yes, it has a count. It returns this value. Okay, now let's say I access value stack dot list size. So it again goes from the top down, looks at this object, list size, no, this object does not have it. Looks at this one, no, this one, yes, it has list size, so it returns this data. And same way for file name. Again, even though this has a file name, it does not return this because it looks from the top down. If you do a value stack get file name, it gets this. Okay, now the question is, how do we access this? Okay, if it's looking from the top down and getting the file name, however can we access this particular string? Well, we can access that by again doing the dot object dot file name, and we're going to look at this in much more detail in the subsequent tutorials. You can actually go through this object graph. There are sophisticated tools and tags for that, but for now, think of it like this. A value stack again is a place where struts2 stores some important objects, and one of the object that it stores is our action object. We learned that there is a new action object that gets created for every request, and we've learned that that action object is pushed on to the value stack. And the reason it's done is because we need those member variables to be accessed in the JSP. So the action object with the data gets stored on the value stack, and then those data are accessed in the JSP. Now, since this data access is a very common operation for the value stack, we need to access these member variables of these objects on the value stack very frequently. So what the value stack does is it makes it easy to access these member variables. You don't actually have to go to the object and then to the member variables. You can access the member variables as if it were a part of the value stack. What the value stack does is it kind of takes the role of a virtual object that has all the member variables of all the objects that it has. So it kind of isolates out all these member variables and treats it as its own member variables. So whenever there is a request for a member variable, it passes through, it goes through all these objects in the order, and then the first one that it finds, it returns the data. So you don't have to worry about getting the object and then the member variable. You can just access it directly. And then, of course, it does name resolution in case there are conflicts, and then it gets the first member variable in the stack that matches the name that you're requesting. And if you need to access anything else, something else that's below, you can actually traverse the object graph and access it. You're not going to worry about how to traverse it for now. We're going to look at that in subsequent tutorial, but this is kind of an overall picture of how a value stack behaves. We are going to leave this here for now. We're going to come visit the value stack and all these concepts in much more detail in the subsequent tutorials. But for now, this should be enough to get us going. And in the subsequent tutorials, we're going to look at a few more tags that make use of the value stack to get the data in the action object that we have saved. Thanks again for watching this tutorial. Hope this was helpful.